Good evening, welcome to my teacher program. Today I am going to take grade 10 chemistry, carbon and its compounds. Carbon is the 14th group element, symbol for carbon is C, atomic number 6, electronic configuration 2, 4. So, if you are just drawing the electron dot structure of carbon, first shell contains 2 electrons and the second shell contains 4 electrons. This is the electron dot structure of carbon. So, normally atoms are taking part in a chemical reaction to attain stability. So, we can see carbon contains 4 electrons in the outermost shell. So, we can see how carbon is normally attaining stability. Ionic compounds normally attain stability by giving electron or accepting electron. So, the two options for carbon are giving 4 electron to form C4 plus ion or accepting 4 more electrons to become C4 minus ion. But normally in the case of carbon, both the cases are not possible. That means the cation formation of carbon and anion formation is not possible for carbon. So, normally carbon attains stability by sharing of electrons, and that type of bonding is called a covalent bonding. So, normally we can see in board papers why do carbon do not form cations and anions. So, that time you have to explain carbon do not form C4 plus ion or cation because the size of the carbon atom is very small. That means the nucleus and the outermost shell of electrons are so close to each other. So, we are normally studying ionization energy that you will study in the next chapter. Ionization energy means the amount of energy required to remove the electrons from the outermost shell. So, since the carbon atom is very small in size, we should have to give a tremendous amount of energy to remove the electrons from the outermost shell. So, in a normal condition, giving that much energy and carry out a reaction is not possible, and that is why C4 plus ion or carbon do not form cation. Now, the next option, carbon C4 minus ion or anion. So, the atomic number of carbon is 6, that means carbon atom contains 6 protons in the nucleus. An atom contains 6 protons in the nucleus cannot hold 10 electrons around their shell. So, generally carbon do not form anions also. So, different way they are normally asking from the examination point of view, the questions are coming in different way. Why do carbon do not form ionic compounds? Or why do carbon do not form cations? Why do carbon do not form anions? Why do carbon do not give electron or accept electron during chemical reaction? All these questions contain same answer. So, the size of the carbon atom is very small and we should have to give a large amount of energy to remove the electron from the outermost shell. So, C4 plus ion is not possible or cation formation is not possible. And when carbon is accepting 4 more electrons, the total number of electron becomes 10. A nucleus contains 6 proton cannot hold 10 electrons around their shell. So, that is the answer. And how carbon attains stability, that is the next question, and that is covalent bonding. Now, we will go the details of covalent bonding. So, generally metals and non-metals, when they are reacting each other, they are giving electron and accepting electron, and ionic compounds are formed. But when two non-metals are reacting together, they are normally sharing the electron and the bond formation is taking place. For example, the simplest non-metal is hydrogen gas. So, hydrogen contains 1 electron. So, to attain stability, hydrogen needs 1 more electron. Only in the case of hydrogen it is not octet, it is duplet, because hydrogen contains only 1 shell. So, the electronic configuration of the nearest helium gas, that is 1s2, or the first shell K shell, contains the maximum number of 2 electrons. So, hydrogen coming and reacting with 1 more hydrogen atom, and the sharing of these 2 electrons happens. and this is normally happens in hydrogen molecule. Two hydrogen atoms coming and sharing one pair of electrons between them. So, this type of covalent bonding is called a single covalent bond, or simply we are calling single bond, and we are representing H single line H. This single line represents the single covalent bond. So, single covalent bond means when two nonmetals making a bond by pairing a pair of electron between them, that is called a single covalent bond. So, H single bond, H or single bond. Now, in the case of oxygen, oxygen atomic number is 8, 2,6 is the electronic configuration. Outermost shell of oxygen contains 6 electrons. So, to complete the octet electronic configuration, oxygen needs 2 more electrons. So, it combines with one more oxygen atom. And here also sharing taking place, and here normally 2 oxygen atoms are sharing 2 pairs of electrons between them. This type of covalent bonding is called a double covalent bonding, or simply we are calling double bond, and which is represented by drawing 2 lines between the elements. And the next one is triple covalent bond or triple bond. Nitrogen atomic number 7, electronic configuration 2, 5. Number of electrons in the outermost shell are 5, and it is reacting with one more nitrogen atom. And here the sharing of 3 electrons are taking place. So, this type of bonding is called a triple covalent bond, or simply we are calling triple bond. This is the normal varieties of covalent bond. If 2 elements are sharing a pair of electron between them for the bond formation, that is called a single covalent bond. If 2 nonmetals are sharing 2 pairs of electrons between them, that is called a double covalent bond, and if 2 nonmetals are sharing 3 pairs of electrons between them, that is called a triple covalent bond. So, carbon outermost shell contains 4 electrons. So, sharing of electron take place in carbon, and carbon sharing, the sharing taking place normally with hydrogen or any other element. So, this is the simplest carbon compound, and normally this type of sharing happens in carbon also. So, the main bonding taking place in carbon atom is covalent bond. So, why covalent bond formation or ionic bond is not possible in carbon, only covalent bonding is possible in carbon? Such type of questions are also normally asking for the exam. So, that time you have to explain, because of the small size and not able to give electron, or not able to accept electron, and the next option is sharing of electron, and as a result normally carbon take place only in covalent bonding. Now, we will see, you have seen when we are burning something, we will get the black residue, that is called ashes, that is mainly carbon, and you have seen in pencils a black lead, that is called graphite. So, when we are burning graphite, we can see that only the residue what we are getting is the carbon dioxide, no other product other than carbon dioxide. Other thing, diamond, when we are heating diamond, that time also we can see that it is the main product when we are heating diamond is also carbon dioxide. That means both the compounds, the main element is carbon. So, simply carbon only. So such type of thing, that means they have same chemical property but they are showing difference in their physical property. You know very well how the appearance of graphite and how the appearance of diamond. You know, so the pencil lead, we are normally going to the stationery and buying a pencil and we can get the graphite pieces, but diamond, you know how much cost you should have to give for diamond. So the some substances, the same element, so normally they are having same chemical properties but they are having different physical property. Such type of existence is called allotropes. And the phenomena by which the existence of such allotropes, that phenomenon is called allotropy. Carbon mainly for carbon mainly three allotropes are there: graphite, so that you have already seen in pencil leads, diamonds, and one more thing is there, that is with a 60 carbon atom. Normally it appears in a football structure and that is called Buckminster fullerene. These are the three main allotropes of carbon atom. Buckminster fullerene, so normally in chimneys and all, when you are seeing the smoke coming out from the chimneys mainly contain this Buckminster fullerene, and also when candlesticks are burning with a yellow flame, that time also that smoke contains Buckminster fullerene. So now we are not supposed to take a detailed study of this Buckminster fullerene, but you have to compare the properties of graphite and diamond, because so many questions are coming from this comparison of graphite and diamond. So in graphite, one carbon atom is attached to three other carbon atom. It is a layer like structure, and one valency carbon, the valency of carbon is 4, and all the valencies of carbon are not satisfied. Only one valency is free in the structure of graphite. Other three valencies are satisfied by other three carbon atom. Normally a layer like structure, we can see a layer like structure is present in graphite, and these layers are just held together by very weak force of attraction, and these layers can slip one over another, and that is why the graphite is a very soft substance. And since the three valencies are satisfied three other carbon atom and one valency is free in the structure of graphite, there is movement of electron, and as a result graphite is a good conductor of electricity. On the other hand, in diamond, one carbon atom is attached to 4 other carbon atom, and it is in a 3-dimensional arrangement, a rigid 3-dimensional arrangement, and this is called a tetrahedral structure, and they are so closely packed, a rigid 3-dimensional structure, and that itself gives the rigid structure for diamond. Diamond is the hardest substance ever known. So that is why, and all the 4 valencies of carbon atoms are satisfied, and there is no chances of the movement of electron. As a result, diamond is a poor conductor of electricity. The questions are coming for the exam. Though graphite and diamond are the allotropes of carbon, diamond is a poor conductor of electricity while graphite is a good conductor of electricity. Generally examination point of view, such questions are coming. That time you have to just explain the structure difference in graphite and diamond. In graphite, one of the carbon atom is attached to 3 other carbon atom and one valency is free. So there is a chance of movement of free electron in the structure of graphite, that makes graphite a good conductor of electricity. On the other hand, in diamond, one carbon atom is attached to 4 other carbon atom and no free valency, no chances for the movement of electron. As a result, it is a poor conductor of electricity. So likewise, comparison you have to study. I hope you know the word meaning of versatile. So versatile means multi-talented, you know the meaning of versatile. So when we are seeing all the elements in the periodic table, generally we are considering carbon as a versatile element. You know, your days start with the brushing of teeth, you are bathing, you are putting on clothes, all these substances, when day-to-day substance, when we are seeing, each and every substance contains carbon atom as one of the component. So why the carbon makes such a millions of compound? What make it possible for the formation of such a million compounds? So we are, because of this carbon's property, carbon is making such a variety of compounds, and that is why we are having a special branch of chemistry called organic chemistry to deal with the only study of carbon and its compounds. So in olden times, it was believed that carbon compounds were not able to synthesize in the laboratory. That was the belief in olden times. So that theory is called vital force theory. But fortunately, when Frederick Wöhler was doing some experiment in the laboratory, he was heating ammonium cyanide. So when he was heating ammonium cyanide, decomposition hasn't taken place, and one of the major product, that is urea, has been formed in the laboratory. So that made vital force theory wrong. So organic chemistry means the study of carbon and its compounds. So why we are having a special branch of chemistry called organic chemistry? Because carbon gives such a millions of compounds. So that itself need a special branch. That is why we are having a special branch of chemistry called organic chemistry. So now we are going to see why carbon make such a variety of compound, and that is called a versatile nature of carbon. Initially we have discussed, so carbon's valency is 4. So generally the 4 valency of carbon atom we are denoting by giving 4 single lines around carbon atom. The 4 valency, because of this 4 valency, it is called tetravalent. Carbon is small size, that initially I told, and second one, carbon is tetravalent, that means the valency of carbon atom is 4. So that is one of the versatile nature of carbon. And the second one, so the carbon atom is having a peculiar property. If I am giving you some beads and a string, if you want to make a chain, you can just make these beads link together to make a chain. So likewise, exactly, carbon atom also has this peculiar property. They can just link one to another in any way. So this way, this way, this way, or any way. So this type of self-linking capacity of a carbon to form long carbon chain. So that property is also make carbon a versatile compound, versatile element, and that property is called catenation. So catenation is the second versatile nature of carbon. The first one is tetravalent and the second one is catenation. Catenation means the self-linking capacity of a carbon to form long carbon chain. That property is called a catenation. That is the next versatile nature of carbon to make such a variety of compounds. And the next one, so I am just going to draw a self linkage of carbon atom, 4 carbon atoms. Okay. So this 1 valency, and for this carbon atom, this is 1 valency and 3 remaining valencies are there, that is satisfied by single lines. When I am seeing this carbon atom, 1 valency here and 1 valency here, 2 are remaining. For this carbon atom also the same way, 1 valency here, 1 valency here, and 2 remaining valencies. And for this carbon, 1 valency here and the 3 remaining valency. So this is called a straight chain linkage. I have connected all the carbon atom in a straight chain. So this type of linkage is called a straight chain linkage. And now 1, 2, 3 and the 4th carbon atom I am giving like this. So for this carbon atom 1 valency, the remaining 3 valency. For this carbon atom 1, 2, 3 valencies are satisfied, so the remaining 1. For this carbon atom 1 valency and the remaining 3. For this one 1, 2, 3 and 4. So this was a straight chain. Without any breakage I can count all the 4 carbon atoms. So for here without breakage I can count these 3 carbon atom, but this carbon atom and this carbon atom is not having any link. So, this is not coming in the straight chain. So, this is called a branched chain. I can make this as a straight chain, no problem, and that time this comes as a branch. If I am counting this as a straight chain, this comes as a branch. So, in this linkage only 3 carbon atom comes in the straight chain and the fourth one is coming as a branch, and this type of linkage is called a branched chain. So, straight chain and branched chain, and these 4 carbon atoms so I made in a closed way. This is called a ring structure. 2 valencies are satisfied, the remaining 2 valency here. Here also 2 valency satisfied, the remaining 2 valency. Here also 2 valency, the remaining 2 valency. So, this is called a ring structure or closed chain structure. So, these are the 3 methods of catenation. That means a self linkage can be given in 3 different ways: straight chain linkage, branched chain linkage, or closed chain or a ring structure. So, now we will see so I have already explained single covalent bond, double covalent bond and triple covalent bond. So, when 2 non-metals are pairing, a pair of electron between them, so that is called a single bond. When 2 non-metals are sharing 2 pairs of electrons between them, that is called a double bond. When 2 non-metals are sharing 3 pairs of electron between them, that is called a triple bond. So, I am going to just rearrange the single bond between this second and third carbon. I am simply going to give the number for carbon atom 1, 2, 3 and 4. Now, I am just going to rearrange the this single bond, the second carbon atom and third carbon atom now linked together by a single bond. Now, I am just going to rearrange that into double bond and triple bond. So, I have drawn the double bond and triple bond. Now, we will see the valency. For the first carbon atom, first valency and the remaining 3. For this carbon atom, 1, 2 and 3 valencies are satisfied, the remaining 1. For this carbon atom also, 1, 2, 3 are over, the remaining 1. For this carbon atom, 1 valency is satisfied, the remaining 3. In this structure, the first one is having 3, the second one 1, 2, 3, 4, no remaining valency. For this carbon atom also 1, 2, 3, 4, all the valencies are satisfied. For this carbon atom a single bond, so the other 3 valency. So, that means in carbon chain itself single bond, double bond and triple bond is possible. That is also another versatile nature of carbon atom. That means the formation of multiple bonds in carbon atom. So, normally when we were discussing about the single covalent bond, we have seen hydrogen and hydrogen was sharing a pair of electron. In oxygen, they were sharing 2 pairs of electron and nitrogen was sharing a 3 pairs of electron. That means we have seen single bond, double bond and triple bond in different elements. But here carbon itself can make single bond, double bond and triple bond. This is called a multiple bond formation. That is also one of the versatile nature of carbon. The first one we have discussed, the tetravalency. Carbon is tetravalent, that is one of the versatile nature, and the second one was catenation. Catenation means the self linking capacity of a carbon to form long carbon chain, and the third one is the formation of multiple bonds in carbon atom. So far we have simply given the straight chain linkage and we did not satisfy other elements in the carbon chain. Now, C, the 3 valencies. So, now I am going to satisfy all the free valencies by hydrogen atom. So far we were seeing only the carbon chain linkage. Now I have written some compounds. Look, 1, 2, 3 carbon atoms. So we are writing C3. 1, 2, 3, 4, 5, 6, 7, 8. So C3H8. This type of representation is called a structural formula, and this is called a molecular formula. So when we are expressing the carbon linkage and all the hydrogen atom in a bonded line, such type of representation is called a structural formula. If I am writing this type of C3H8, so this is called a molecular formula. Here 1, 2, 3, 4 carbon atom and 10 hydrogen atom. So C4H10. So this is the structural formula and this is the molecular formula. Now I am just going to rearrange this straight chain into a branched chain. 4 carbon atoms are there. Now this is a branched chain. Now all the valencies are satisfying by hydrogen atom. Okay, 1, 2, 3, 4. 4 carbon atom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atom. So look, here C4H10, but the carbon atoms are arranged in a straight chain. Here also the molecular formula C4H10, but the carbon atoms are arranged in a branched chain. That means the molecular formula of both the compounds are same, C4H10, but the structural formula is different. Such type of arrangement is called isomerism, or they are called isomers. This phenomenon is called isomerism. These compounds are called isomers. So now we will see, so before explaining, so the compounds which contain only carbon and hydrogen, such type of compounds are called hydrocarbons. So before moving a detailed study of isomerism, so I have to explain about the hydrocarbons. So hydrocarbons, as the term suggests, hydrocarbons. It's very clear from the name itself, hydrocarbons means the compounds which contain only carbon and hydrogen. Such type of compounds are called hydrocarbons. So hydrocarbons are mainly divided into two categories. They are called saturated hydrocarbons and unsaturated hydrocarbons. So when we were seeing the versatile nature of carbon, we have seen carbon has the capability of multiple bond formation. On the basis of the multiple bond formation, we are categorizing the hydrocarbons into two categories: carbon-carbon single bond. Carbon-carbon single bonded compounds are called saturated hydrocarbons, and unsaturated may be carbon-carbon double bond or carbon-carbon triple bond. Unsaturated hydrocarbon includes both carbon-carbon double bond or carbon-carbon triple bond. Saturated means carbon-carbon single bond. So this carbon-carbon single bond last year in grade 9 in atoms and molecules we have already studied. So, normally the newly found elements and compounds, the names are given by some authority, that is called IUPAC. I hope you know the full form of IUPAC, International Union of Pure and Applied Chemistry, that is IUPAC. So, they are giving all these names and formula, they should have to accept, then only we can give. So, the saturated hydrocarbons according to the IUPAC rule we are calling by a name. So, carbon-carbon single bonded hydrocarbons are called alkanes. They are called alkane. So, unsaturated hydrocarbons can be either carbon-carbon double bond or carbon-carbon triple bond. Carbon-carbon double bonded compounds are called alkenes and carbon-carbon triple bonded compounds are called alkynes. So, it is very easy to identify carbon-carbon single bond, double bond and a triple bond. So, single bond means ANE, double bond means ENE and triple bond means YNE. So, that is carbon-carbon single bond ends with ANE, carbon-carbon double bonded compound ends with ENE and carbon-carbon triple bond ends with a YNE. So, now we will go in a detailed way how we are normally forming the structural formula and molecular formula for this alkane, alkene and alkyne. Before that, so it is very important to study the nomenclature and naming of carbon compounds according to the rule of IUPAC. Generally, hydrocarbons are named on the basis of the number of carbon atom present in the carbon compound, in the hydrocarbon. So, in when we are seeing for the 10th grade up to 6 we are studying. So, carbon atom, number of carbon atom. So, in a hydrocarbon, if the number of carbon atom is 1, so we are calling it as a root word. The name of that hydrocarbon should start with the word meth. Number of carbon atom is 1. The root word for that hydrocarbon starts with meth. For 2 carbon atoms, it is eth. 3 prop. 4 bute. This is not but, you have to pronounce it as bute. 5 carbon atom pent. 6 carbon atom hex. 7 carbon atom hept. 8 carbon atom oct. 9 non. 10 duck. There is no need to study all the 10. For 10 CBSE you have to study minimum 6 carbon atom. Okay. So, now we have studied 3 different categories of hydrocarbons: alkanes, alkenes and alkynes. So, according to the name, according to the bonding between the carbon atom, if all the carbon bonding are carbon-carbon single bond, the name should end with ANE. That means carbon-carbon single bond. Meth is the root word for single carbon atom, so it should end with ANE. So, this is methane. So, second one ethane, propane, butane, pentane and hexane. This is for carbon-carbon single bonded hydrocarbon ending with the ANE, that is alkane. So, if this is alkene, it is very easy: methane, ethene, propene, So likewise it is going. So if it is YNE, METHYNE, ETHYNE, propyne, likewise. I hope you got clear. So the hydrocarbons, according to the IUPAC rule, we should have to name the hydrocarbons on the basis of the number of carbon atom present in the carbon chain. If only one carbon atom is there, the root word is meth, 2 carbon atom eth, 3 prop, 4 bute, 5 pent, 6 hex. And if the compound is alkane, that means ending with the ANE, methane, ethane, propane, likewise you have to name. If C double bond C is present, all the root words should be ending with the ENE, and if C triple bonds are there, it should be ending with the YNE. Here normally you are making mistake. When a teacher is giving you to make a pattern for this hydrocarbons of alkane, alkene and alkane, you should have to, the teacher will explain, okay, you should have to just add ANE, ENE or YNE to the root word, and you just make a table for alkane, alkene and alkane. So obviously suddenly what you will write, okay, meth, that is the first carbon atom. So ending with the ANE, that is carbon carbon single bond, so we will write methane. Okay, that is correct. And the second one is, it should end with the ENE, so we will write METHENE. And the third one is ending with the YNE, we will write METHYNE. But you have to listen, this methane and methane is not possible. That means if we want to get an unsaturated hydrocarbon, minimum 2 carbon atoms are needed, because unsaturated hydrocarbon means carbon carbon double bond or carbon carbon triple bond. That means the double bond and triple bond should be in between 2 carbon atoms. So for making a double bond or triple bond, minimum 2 carbon atoms are needed. So meth means only 1 carbon atom. A single carbon atom cannot make a double bond or triple bond between them. So it can make only single bond with the other element. Okay. So see, this methane and methane compound is not possible. The simplest alkene starts with the minimum 2 carbon atom, that is ethene. So normally board exam they will ask, write the third member of alkene series, write the third member of alkyne series. So after studying the correct order of meth, eth, prop, normally we will write propene or propyne. So here ethene is the first member, propene is the second member, and butene is the third member. So for alkene and alkane, bute comes for third member. Bute means number of carbon atoms are 4, but in the case of alkene and alkane, the carbon atoms with a single carbon atom compound is not possible, because that alkene and alkane should contain carbon carbon double bond and carbon carbon triple bond. So with a single carbon atom, double bond formation and triple bond formation is not possible. So ethene and ethine are the first member in the alkene series and alkyne series. Always you have to keep that in the memory. So because when by counting meth, eth, prop, normally you will make mistake. The first member in alkene series and alkyne series starts with eth, 2 carbon atom. So after explaining this, again we will go back to isomerism. I was just going to explain isomerism, because when I was writing that compound, it is not possible to name the compound if you don't know this naming. That is why I again went back and I explained this. So isomerism, once again I will explain isomerism. So C 4 carbon atom, C4H10, this is called a straight chain linkage. So this is called a branched chain linkage. In both the case, the molecular formula is same, C4H10, C4H10, but the structural formula is different. They are called isomers, and this phenomenon is called isomerism. Now we will try to give the name for this compound. So C4H10, 1, 2, 3, 4 carbon atoms are there and 10 hydrogen atoms are there. So according to the IUPAC rule, meth, eth, prop and but, and all are single bond, so it should end with the ANE. So the name of this compound is butane. Butane. But here, according to the IUPAC rule, we are naming the compound on the basis of the longest straight chain. We are not supposed to break the chain. The longest straight chain should take us our parental chain. So here 1, 2, 3 carbon atoms are in a straight chain, and this is coming as a branch. So here again we have to study another group, that is called alkyl group. Alkyl group means from normal alkane, one of the hydrogen atom is removing and the remaining part is called alkyl group. So the first one, when we are writing the chemical formula, structural formula and molecular formula, the simplest hydrocarbon is CH4. The name is methane. The next member with the 2 carbon atom. What it is forming? C2H6, 2 carbon atom. The name is ethane. Now with the 3 carbon atom, C3H8 propane. Now with the 4 carbon atom, butane. So I am not writing the rest, I am just making the first 4 members. So here this type of formula is called a structural formula and this is called a molecular formula. You just see how the progression of the molecular formula happens in the higher when the number of carbon atoms are increasing. The first formula CH4, that is methane, second one was C2H6 and the third one was C3H8 and C4H10. The number of carbon atoms are increasing one by one. 1, simply C means 1 carbon atom, 2, 3, 4, that means the number of carbon atoms are increasing one by one. Hydrogen atom, when we are looking, the first case CH4, 4 hydrogen atoms are there. In the second member 6 hydrogen atom, and in the third member 8 hydrogen atom, and in the next member 10 hydrogen atom likewise. So the number of carbon atoms are increasing one by one and the number of hydrogen atoms are increasing 2. That means when we are taking the 2 consecutive members of alkane or alkene or alkyne, what happens? There is always having a difference of CH2 group. C2, the difference is 1 carbon atom. C4, C2H6, the difference is 2 hydrogen atom. So when moving to these 2 members, CH2, when the next member CH2. That means when we are making one by one, the increasing order of the number of carbon atom, the consecutive members are always having a difference of CH2 group. So, exactly like how you are studying the series formation in mathematics, here also always the consecutive members are having a CH2 difference. You are adding CH2 to the next first member and you are getting the next member. Again CH2 to the second member, then we are getting the third member. So, likewise it is going, that means we are making a pattern or series of compounds. So, this type of series this series of compounds are called a homologous series. So, that means when the hydrocarbons are writing in the order of increasing number of carbon atom, always the consecutive members are having a difference of CH2 group and they are forming a pattern or a series, and such type of series or pattern are called a homologous series. So, when you are seeing homologous series under the same category, all are coming under general chemical properties, that means CH4, C2H6, C3H8 all are having the same chemical property because they are coming under the same structural pattern. But when we are seeing the physical property, you can see from the first member to the next member, normally the gradation in physical properties are taking place. Now, why the gradation in physical property is taking place in homologous series? Because physical properties are mainly depends upon the atomic mass. Physical properties normally varies according to the mass of the substance. So, the consecutive members are having a difference of CH2 group. You know the atomic mass of carbon atom is 12 and that of hydrogen atom is 1. So, CH2 group means 12 plus 2 hydrogen atom, atomic mass is 2. So, 12 plus 2 14 U. You know atomic mass is represented by the unit U, or before it was atomic mass unit, now we are simply writing U for the atomic mass. So, when we are just calculating the atomic mass of the first member, the second member is 14 unit more than the first member. When we are taking first member and the third member, 14 plus 14, 28. So, likewise there is a gradual gradation in the atomic mass of the all the homologues. So, each and every members are called homologues. Since the atomic mass is keep on increasing or the consecutive members are having a difference of atomic mass of 14 U, they are showing a gradation in physical property because physical properties are mainly depends upon the atomic mass of the substance. They are coming under the same structural pattern, that is why they are having similar chemical property. So, all the homologues in the homologous series are having same chemical property, but they are showing gradation in the physical property. The same thing happens in the alkene and alkynes also. Now, we will just see the electron dot structure of these first members of all the three, that means alkane, alkene and alkyne. So, the first member alkane, the first member was methane. Methane is very simple because carbon atom, the molecular formula is CH4. Carbon atom, carbon contains 4 electrons in the outermost shell. It is sharing one electron with a hydrogen atom. This is the electron dot structure of methane. So, normally they are asking, so draw the electron dot structure of, in majority of the time they are asking ethene and ethine. Methane is also important, but you have to study ethene and ethane. Now, that is the first member of alkene. Ethene. Ethene, C, double bond C, so whenever you are going to draw the electron dot structure, it is always better to write the structural formula first. So, here it is very clear, these two carbon atoms are sharing 2 pairs of electrons between them. So, first of all you have to draw the sharing of electrons in carbon atom. This double bond means they are sharing 2 pairs of electron. For this carbon's 2 electron and this carbon's 2 electron. So, for this carbon atom remaining 2 electrons. So, 1, 2, 3, 4 electrons for this carbon atom, and for this carbon atom 2 electron and the remaining 2 electrons. And now these electrons are shared by hydrogen atom. So, carbon carbon double bond. So, this is the electron dot structure of ethene. It is very important, you have to study properly. So, before drawing the electron dot structure of ethene and ethyne, it is always better to write the structural formula first, so that it will not make any confusion. On seeing the structural formula, it is very clear, carbon carbon double bond. So, we should have to share 2 pairs of electron and single bonded hydrogen. So, 1 electron of hydrogen atom. Okay, this is ethene. Now, we are going to draw the structure of ethyne. So, carbon carbon triple bond. So, 3 valency plus 1 valency, 4 valency. Here also 3 valency plus 1 valency, 4 valency. So, it is very clear these 2 carbon atoms are sharing 3 pairs of electrons between them. So, this carbon atom 3 electrons. For this carbon atom 3 electrons. So, 3 pairs. So, for this carbon atom 1 electron is remaining. For this carbon atom also 1 electron remaining, that is bonding with a hydrogen atom. So, this is the electron dot structure of ethyne. So, you have to study the electron dot structure of methane, ethene and ethyne. So, now we will see the general formula, how these hydrocarbons are making a general formula for the formation of these compounds. So, the first one of this alkane was CH4 and alkene C2H4 and alkyne C2H2. The second member C2H6, C3H6, C3H4, C3H8, C4H8, C4H6, C4H10, C5H10, C5H8. So, now look, 1 carbon atom increasing and 2 hydrogen atoms are increasing. Here also 1 carbon atom increasing, 2. So, all the 3 forms a homologous series. So, here for alkanes it is easy for us to make a general formula Cn H2n plus 2, where n is the number of the carbon atom. Look, C1, H 2 ones are 2, 2 plus 2 4. So, that is CH4. For the second member C2, so 2 2s are 4 plus 2 6, and this is the general formula for alkane Cn H2n plus 2, that is the general formula for alkane. This is very easy, 2 2s are 4, 3 2s are 6, 4 2s are 8, 5 2s are 10. So, it is double. So, it is the formula is Cn H2n. This is the general formula for alkane, and here 2 hydrogen atoms are less when we are comparing here. So, Cn H2N minus 2. So these are the general formulas of alkane, alkene and alkyne. Okay, these are the different formula, the general formula for alkane, alkene and alkyne. So just we will see the recap. So what all we have discussed today. So the carbon, the size of the carbon atom is very small. Normally carbon do not form cations and anions, and you know, I hope you know the reason, and that is normally carbon taking place in a chemical reaction, or carbon makes a bond through sharing of electron. Sharing of electron happens in 3 different ways: single pair of electron sharing, and double 2 pairs of electrons are sharing, and 3 pairs of electrons are sharing, namely single bond, double bond and triple bond. All the 3 bond formations are possible in carbon atom. Then we have seen the versatile nature. Carbon, the valency 4, that is called a tetravalent, and we have seen the self-linking capacity of a carbon atom, that is catenation, and the formation of multiple bond. So that is also another thing. And next I have explained the homologous series, and hydrocarbons also I have explained, the compounds formed by carbon and hydrogen. They are mainly classified into saturated hydrocarbons and unsaturated hydrocarbons. Saturated hydrocarbons, carbon-carbon single bond with alkane, and unsaturated double bond with alkene, and unsaturated itself carbon-carbon double bond or triple bond, alkene and alkane, and their general formula we have seen. So hope you have enjoyed. Go and revise all these portions nicely. Okay, thank you.